round out this conversation of amounts with a sort of a nod in the direction of other, right? So we use molarity mostly, but it turns out there are some other units for concentration that we use. And one of them is mass percent. And by the way, the reason I'm only going to give a nod to these is because they make sense. They're probably going to have to practice them before you like them, but these are not like molarity. Like, you'd have to know what the definition of molarity is before you use it. But things like mass percent, this makes sense. And if you go back to your SAT days, when you were practicing for the SAT, or not, right? Then a mass percent is simply a mass of the part over the mass of the whole. And if it's a percent, we're going to multiply by 100. So mass percent is a mass per mass, okay? And here's an example of a mass percent. If you look at bleach, I guess this is Clorox, you would see that bleach is 7.4%. Can you see that? Sodium hypochlorite. Sodium hypochlorite, which is a base, all right? Not a very strong base, but a base, all right? Sodium hypochlorite is what bleach is, and it's 7.4% by mass. That means we have 7.4 grams of sodium hypochlorite per 100 grams of bleach, right? That's the solution, okay? That's what that 7.4% by mass means, all right? So volume percent, of course, is the same thing. Volume per volume, okay? And mass volume is also used sometimes. I remember a story when I lost my page there. What was that? I was starting to work in a lab. I went and got a job at the University of South Florida in the College of Medicine. There was a lab that I was working in, and it was for a professor named Ray Olson. And I'm not going to tell you the whole story. Suffice it to say, I just finished my chemistry degree, walked in, and somebody said, I want an 11% HCl solution. And he wouldn't tell me if he wanted mass per mass or volume per volume. It turns out the most common use for solutions like this is mass per volume. And so that would be, for example, 11 grams of HCl per 100 grams, or no, 100 mils, almost missed it right there, 100 mils of solution, right? Can you read my writing? 11 grams per 100 mils of solution would be an 11% HCl solution. I'll tell you more of that story later. It's not interesting, I warn you now. Okay. Now, it turns out that we have mixed concentrations that are oftentimes used in different settings, and that's just because it's convenient for them. For example, if a nurse is going to come and hang saline solution so that your blood volume doesn't get too low, right, and put this in a port in your arm or your neck, then we're going to use saline solution, which is 0.9%, and it turns out it's a mass per volume. That would be 0.9 grams of sodium chloride per 100 mils of the saline solution, which I'm just going to write as 100 mils. I guess I'll write saline. Okay? That's what the 0.9% would be. And we use other things. For example, diabetics have got to measure their blood sugar all the time. And so they'll put a drop of blood on a little tab and stick it in there. That's oftentimes done in milligrams per deciliter. And then you might ask, why is that? And I'll say it's because it makes for convenient numbers. That's why we use weird units like that. All right, so be on the lookout for these. You'll always be given definitions as you go along. So the important point is to be able to piece your way through them and figure out what's the part and what's the whole, and then divide, right? All right. The final one I want to describe to you is parts per million and parts per billion. And so parts per million, and these are oftentimes used when analyzing, for example, drinking water or whatever, right? Something that's got a very small mass of solute, but important. It's got a small but important mass of solute per mass of solution. We're going to say parts per million. And believe it or not, if you have something like mercury in your water, parts per billion are important, right? Even if it's a very small amount, parts per billion is still significant, and it's something that could be possibly dangerous to you. Okay, so parts per billion is going to be a mass per mass times a billion. parts per million is mass per mass times a million. Those are parts per million and parts per billion. And as I said, we use those when we're doing things like analyzing drinking water and other things. All right. Hope this is helpful.